Hi, welcome to part four of this sort of mini series discussing predictive processing and the two books, The Predictive Mind and Surfing Uncertainty by Andy Clark. I think now's a good time to do a sort of short recap of what we've found and the concepts that are in the book. So we covered a few things in the last few videos, but really it's that the conclusion is that the brain is an inference machine. It uses a layered hierarchy to maintain a balance of top-down predictions and bottom-up sensory input. And it does this by utilizing prediction errors to update prior expectations and generate better models. And hopefully by now, I know it's quite wordy, but hopefully by now that starts to make sense. And if it doesn't, then please revisit my previous videos. And the result is that what we perceive is the brain's best current inference. That our perception is sort of, in a sense, it's like a simulation of what the brain, the best guesses that the brain has. And these best guesses are constantly being revised as new information comes in. And it can be summarized by this sort of quotation: perception is a controlled hallucination. So this sort of begs the question, if perception is a controlled hallucination, and we think of most of our daily life not as a hallucination, what would perception look like if it was out of control, if it wasn't controlled very well? So this is really when prediction processing comes in to have something to say about psychosis. And the predictive processing model of delusions and hallucination formation are when certain disturbances, either in dopamine or other modulatory neurotransmitters, those disturbances mean that sensory information is predicted to be less precise, noisier, and more uncertain than it actually is. And if we just think back to the last video about precision expectations, this means that they've got low precision expectation on incoming sensory information. Because of this low precision expectation, it decreases the gain on the sensory input, so it decreases the gain on the prediction error units. And this means there's less prediction errors propagating up the hierarchy. And it means there's a heightened reliance on top-down priors. And this theory is fairly attractive in the fact that there's research that's showing that dopamine transmission is important in the precision expectations. That dopamine plays a role in the signal to noise ratio, to working out the signal to noise ratio. Okay, so what does this mean then? So we've got a dampened down error signal because of turning down the gain. Well, this means that without the prediction errors going up the hierarchy, it's going to be inefficient at regulating ongoing revision of prior beliefs. So those higher level beliefs at the higher levels of the hierarchy just aren't going to get the prediction errors, and they're not going to be revised, meaning that they can stray away from reality. That these higher level beliefs are unsupervised by the sensory input. In addition, it means that because the gain's been turned right down, relatively small but significant prediction errors are treated as noise instead of signal. So this means that we've got more reliance on those top-down predictions. But it also means that if there is a larger prediction error that makes its way through, it's going to stand out and be exceptionally salient against the background of subdued prediction error. And this is something that you might see with people experiencing psychosis, is that small things that don't seem majorly important or significant suddenly take on a great importance. And this is a possible mechanism for why that might occur. So under this sort of model, then we can see the delusions are conceived of as wild hypotheses that are permitted to reign unchecked by sensory evidence. And hallucinations are not the sort of the classical definition. They're not perceptions in the absence of sensory information. The sensory information is there, but perceptions due to the distrust in the sensory information and an undue influence of prior expectations. And that seems to be reflected in the research as well, that the expectations have undue influence over the perceptions. Okay, so that just covers a little, like one sort of consequence of predictive processing. Now, I think people will be thinking, well, whereas actually, a lot of this is kind of conceptual, slightly philosophical, whereas the evidence for this theory. And both books are well supported by references to studies. I haven't been able to read through all those studies, but it's something that I definitely will start working my way through, at least the ones that I can understand. But at the very least, I think this theory is a useful framework, and it has something to say on a lot of different topics, and it's supported by different studies in cognitive science, such as binocular rivalry is mentioned in both books, the hollow mask illusion, emission-related responses, the rubber hand illusion, context sensitivity, self-tickling, etc. I won't explain. I won't go through all of these, but these are some of the experiments, and then using predictive processing to make sense of the results from those different experiments. Okay, so there are many other topics under the banner of prediction processing. Not least to say action in the motor system, emotion, and consciousness. And I might get around to doing further videos and talking about some of these things. But I hope that I've set the scene enough for you to go and read Howie and Clark's books for yourselves. I'm going to end with this sort of summary, that classical theories of sensory processing view the brain as passive, stimulus-driven device. By contrast, predictive processing emphasizes the constructive nature of perception, viewing it as an active and highly selective process. In predictive processing, top-down processing is happening all the time, and it's a core feature of brain function. I'm going to leave some links in the description for further reading, so please check those out if you're interested. And I apologise if I've made any errors throughout these videos. I make no claim to be an expert, but in the spirit of predictive processing, do let me know so I can update my current model. I hope you've enjoyed this short series, and yeah, let me know if you want any more content on the topic.